Okay, so each graph had a critical point at x equals -1. You're going to compare and contrast the first and second derivatives to the left and right of x equals -1. All right, so from the left of x equals -1, the slope is -1 as x approaches -1 from the left. And from the right of -1, as x approaches -1 from the right, the slope is +1. All right, so there is no derivative at this point. Okay, the second graph, the derivative is equal to 0 as x approaches -1 from the left. The slope of the tangent line would be 0. As x approaches -1 from the right, the slope is also 0. So the derivative is 0 there. Okay, and the last graph, as x approaches -1 from the left, we have no slope. The graph gets very vertical. And as x approaches -1 from the right, we also have no slope. Vertical lines have no slope. Okay, very important. Please note that all three graphs have a negative slope to the left of x equals -1 and a positive slope to the right, but they are all different graphs. So we're going to have to do a lot more work when we are trying to describe a graph without a calculator. We're going to have to look at more than just the slopes to the left and the right. We have to consider the curvature, which is the second derivative. The second derivative will tell us about the curvature of the graph. But the first derivative is nice because it tells you increasing, whether the f of x is increasing or decreasing, and can help you get a max or min. Okay, so for this one, you're supposed to fill in the blank. Function f is defined and continuous on the interval -2 to 5, including the endpoints. I went ahead and plotted all these points. The only critical points are at -1 and 2. The function has values as given in the table. So I plotted all those points. The value x equals 2 locates the absolute minimum. A critical point is a point where there's a major change in the graph. So the only place you could have a change would be at -1 and 2. So at -1, that would have to be, since there are no other critical points besides this one, that would have to be an absolute maximum. Otherwise, there would be another critical point if they had a point that went higher. At x equals -1, f of x equals 2 is the highest point, and this is also the highest point. At x equals 2, the absolute minimum, because if we had any points that went lower, then we would have to have another critical point to turn the graph back around. Okay, if x equals 2 is the only critical point and we have the second derivative as negative, that means the graph is concave down. Concave down would have to have a maximum, absolute maximum point. Okay, if f prime of 2 equals 0, and f prime changes from negative to positive at x equals 2, that means that f of x is decreasing, getting flat, and then increasing. That would be a minimum. We don't know if it's the absolute minimum. We just know for sure it's a minimum. So we'll say a local or relative minimum. Okay, for number 4, if f prime of 2 equals 0 and the second derivative is greater than 0, that means f of x is concave up. Concave up is like a U shape. And that would be a minimum value there. We don't know if it's the absolute minimum because we don't know if there are other critical values. Okay, number 5, if x equals 2 is a critical point and f prime of x decreases, okay, if f prime is decreasing, that means we have concave down through x equals 2, curving down, so it's an upside down U. That would have to be a local maximum, since we don't know if there are other critical points. Number 6, if a continuous function increases through a closed interval, then the left endpoint would have to be the absolute minimum, because you've got an endpoint and then on the left, and the graph keeps going up, f of x keeps going up, and that's an absolute minimum then. Okay, student found the critical points of a function to be at 2 and 4. The only major changes on the graph occur at x equals 2 and 4, and produced the chart below. So we have a graph that has a positive slope to the left of 2, so that means f of x is increasing to 2. After 2, the graph turns around and decreases, so that should be a maximum at 2. And then at 4, the graph changes from having, f of x changes from going down, decreasing, to going up, so that's a minimum. And we don't know if those are the only critical points, so we have to say relative minimum on that one. Okay, last but not least, the last scenario, if you have x equals 2 is the only critical point of the function, and the second derivative is equal to 3, positive. The second derivative tells you about concavity, so that would mean f of x is concave up, because we have a positive second derivative. Concave up is like a u, 2 is at the bottom of u, that is the absolute minimum.